All right, welcome back to Hipster Code. So a couple of weeks ago, one of the commenters suggested on doing a video on .loc versus .iloc in Pandas. So briefly, I covered Pandas and using Pandas and Python to go through CSV files, comma-separated value files, and using Jupyter Notebooks here, we did a short analysis on CSV files, and I showed the .loc method and how you can use it to filter data. But there's also a .iloc method in Pandas, so I'm just going to do a really brief overview on the difference between the two and why you might use one versus the other in specific situations. So we're going to be looking through mostly this vetappointments.csv file. You can tell it has name of a pet, the species, the breed, the age, an owner name, and the reason that they might have gone to a veterinarian's appointment. Of course, this is all ChatGPT data, but we don't need to worry about that because it's going to work for our purposes. At the end of the video, we're going to briefly look at the also a CSV file on the number of cats in a specific country. Also, the data might not be 100% reliable, but let's go and check out this vet appointments CSV file. If you want any of the code, it is going to be posted in a Google Docs that should be linked below. Also, if you want any information on how to use Pandas, I did make a video on that a couple of weeks ago, as I mentioned. So we are going to import Pandas as PD. And let's go ahead and bring in this first CSV file, the vetappointments.csv, and let's just call it df for data frame. The way that we bring in CSV documents is with the read CSV method on our Pandas object. And then we can bring in vetappointments.csv. And let's just check out this this CSV and the way it comes in as the data frame. And it's only 50 appointments, right? So doing df actually gives us the entire data frame. Let's go and do df.head just so we don't have to deal with as many appointments, just so we can actually check out the data. And as you can tell, it's coming in. Let's see if this is coming in as an integer, just to make sure that our data types are coming in as something that is usable. It is. So everything else is an object, but we can still deal with them because essentially they're Python objects that are Python strings, so we can still deal with them. So I'm not going to go through and change any of the data types or anything like that. So if we wanted to use the loc method on our data frame, I think it's for location. You actually don't invoke it like a method. So it might be an object. I actually need to look into what exactly it is. But you call it, you drill through your data frame, you do .loc, and then you actually use the square brackets. And then this is where I showed off in the Pandas video, how you could use it to actually filter, right? So if we wanted to find all of the animals that were older than 2, we could do df.loc and then filter by the age column and then say it's greater than 2. And then that's actually going to give us a list of all of them that are older than 2. Is this right? Oh, yeah, it is. Yep. So you could see how many we have here. We could tell how many there was by then putting it in the length function in Python. You can tell there's 39 on our list, so it's actually the majority. So that's what we were using the loc method for earlier, but actually you don't just have to utilize it to filter the data like so. You can actually use it to go through and grab a selected amount of rows, not just through filtering, but through numbers as well. So actually the way that it works is loc is based on label. So for the columns, it's the column name. And for the index, it's the actual index value. Now, it's going to look very much like the iloc method here at the very beginning, because most of the time when you're dealing with data frames, the index value is going to be an integer like so. And so the way that the loc method is actually built out is the first argument is you're selecting which rows you want. And so another way that we could actually select a certain number of rows is based off of the index, and it is inclusive. So we could say the 0th index to, I don't know, let's go to the 9th. Let's go to the 9th index. And then it actually takes in a second argument, which is which columns you want. So we could say we want the name column and the age column. If we did that, you can see we actually limit the columns we get. But that first argument, which is what we're really doing when we're doing that filter method that I showed before, is getting us all of them based on the index in this circumstance. So we're getting between the 0th index and the 9th index based off of the actual number. For now, we can ignore the second argument. It is good practice to put in the second argument. If you wanted to get all of the columns, and you could either ignore the second argument and it's going to give you all of the columns, or you could do this if you wanted to be explicit and still put in that second argument. Both of them are interchangeable. Some people think this is better. I think so in certain circumstances. It's more explicit. The other way is more implicit. But for the purposes of this video, the iloc method is based off of the actual value of the index. Let's load in the data frame again, but let's call the iloc method on it. And let's try and do the same thing. So we're going to do from the 0th to the 9th. So the iloc method is actually using the index, but the label of the index. The iloc method is going to use the index, but the integer value of the index. So it's going to be, I'm kind of confusing my words here, but it's going to be more obvious here in a second how it's different. Immediately, it's not immediately apparent how it's different, other than the first one, we actually have this 9th index row here. So the first immediate difference is iloc is not inclusive of the last value, but the iloc method is inclusive of both the first and the last values. That's one of the differences. However, like we could go over here and say we wanted the name column, right? So we're just going to get all of the name columns here. The columns also have their own integer value. So we can't say the name column in the iloc method. We're going to get an error. What you have to do is say, okay, let's get the 0th through the 4th column. And then you can see that gets a 0, 1, 2, 3, and then 4 isn't going to be included because it's not inclusive. So they're the actual integer value of both the columns and the rows. But because our index is an integer itself, it looks very similar. But a way to actually notice the difference is let's take our data frame and let's eliminate some of the values, right? So let's just say that we're going to get all of the appointments that are annual checkups. And of course, the way that we could do that, like I showed, I like the iloc method. So let's just use the iloc method to find out where the, what is this called? The visit reason is equal to, annual checkup. Is that capitalized? It is. They're both capitalized. So let's go ahead and get all of these. And you can see we have significantly less. So we have the 0th index, the 6th, the 11th, the 17th, 33rd, and 45th. So we have significantly fewer values. If we wanted to take this, let's save it to another data frame and then use the iloc and the iloc method on this new data frame. So I'm going to save this to df2. And then just to make sure that it's still returning the df2, I'm going to return it down here so we still see it. But now let's use the iloc method on df2 instead of df1. And let's grab, once again, between the 0th and the 9th index. And look, so because the actual value, the label value of the actual index is 0 and 9, we're getting between the values 0 and 9. So 11, 17, 26, 33, and 45 are not included with the iloc method with this particular way that we're filtering our data frame. Let's try it again with the iloc method, and let's do 0 to 9. And this is the key difference, is we are not doing it based on the value of the index. We're doing it based off of the value of where it actually is at in the row position, if that makes sense. So it's the integer indexing versus the label indexing. Is if you Google the difference between these two is what it's going to say. Again, that's kind of hard to visualize, but I think this is making a lot more sense now because you can see using iloc, we're doing it based off of the actual label, 0 to 9. So we're getting between all of the indexes that are between 0 and 9, we eliminated in df2. We eliminated 1, 2, 3, 4, 5, 7, 8, 9, 10, and we just have 0, 6, and 11 left. So you can see that's the ones that it's limiting it to whenever we get our new data frame returned based off of the loc method. The iloc method doesn't care about the actual value of it. It cares about the integer position of it. So it's treating this as 0. It's now treating 6, not as the value 6, but as 1, the integer position of 1, 2, 3, 4, 5, 6. So we actually get all of them. If we did, I don't know, let's say 3 instead, you can see we get 0, 1, 2, and then it is not inclusive of 3. So you can see that's the difference. If we want to do this with 3, we actually no longer get the value of 6 because it gets thrown out with the loc method. The iloc method does include it though because it doesn't care about what these actual values are. It cares about the position of it in basically this list of rows. The reason that I have this cat countries here is because I thought it was going to be a little bit more clear example of the iloc method, because we have unique countries and then we have a fake number of cats. Again, like Australia, it's estimating, 4.75 billion cats and a cats per capita of 0.2. Maybe this is accurate. I have no idea. Again, it was ChatGPT. So let's go ahead and bring this in. Let's just call it df3 because I'm not very creative with my names. Let's read CSV, and this is called catscountries.csv. So catscountries.csv. Let's see what we got. And of course, this is the top 5 rows. And because each country is unique, this is actually an example of a data frame that we might not want the automatic index to just be an integer, right? This is an auto-incrementing integer is what it automatically makes the index. We can override this whenever we create our data frame. And the way that you override this is to say, instead of having the automatic auto-increment integer for our indexing value, we want to say the index call for index column is going to be equal to, and then we're going to give it a column name. And because each country name is unique, this is actually makes it a good candidate to make it our index. So let's rerun this. And now you can tell the index itself, the way that we would actually search this up with loc is now not a number, but a string, right? So if we wanted to go and use the .loc method and we wanted to find, here, let's see the entire data frame. Hold on, let me delete this. We can see the entire data frame. It's only 25 values, so we can actually look at the entire data frame to make it a little bit easier. So if we want to say, let's grab between Canada and Hungary, because these are the values for the index, right? The label values, right? This is why it's called label indexing. We have to say, using .loc, that we want to select between Canada and what did I say? Hungary. So we're going to say Canada, Hungary. So we're using the colon the same way that we would if it was between 0 and 7 or whatever the value is. But because our index is no longer an integer, using the .loc method, we can't use integers to actually limit which rows we want anymore. Now you can see this is becoming a little bit more clear. So the loc method, because our index is no longer an integer, we actually have to use the values themselves. Now, this is automatically in alphabetical order. I haven't really tested this to see if you load them in non-alphabetical order, maybe it automatically reorganizes them. I'm not actually sure about that. I'm not generally a big fan of making something like this your index. If you had like a bunch of orders for some sort of company, right? Like some sort of store had a bunch of orders in a CSV and it had a unique order code, maybe that's a good reason to make that the index instead. But something like this, I would probably still keep the integer value, but it's not really hurting anything. But again, it just makes it a little bit harder to you have to spell it 100% exactly right. Like this is kind of arbitrary, selecting between Canada and Hungary, but it's totally fine. Again, the point of the video is using the .loc. We have to use the values of the index. .iloc, let me just show you with iloc, trying to do the same thing the same way, and as you can imagine, it is not going to work. What, Hungary? It doesn't matter if I spell it right, because we are going to get thrown an error because iloc doesn't care about the value. Once again, the iloc cares about the integer index, right? It is always the integer index based off of your data frame and the integer of what position it is numerically. So this is going to be 0, 1, 2, 3. So if we wanted to select the first 5, right, we would say between 0 and 5, right? So that's going to get us the 0th index, first, second, third, and fourth index. And again, the 5th index is not inclusive, but because it does include the 0, we actually get the first 5. And so notice we didn't actually give it the values of the index. We gave it the integer value of the position of the row. Now, again, it is kind of hard to explain, which is why I think there's so many not perfect explanations out there. And that's why I was hoping that these actual examples demonstrates the difference between the two. So let's just review it really quick. So whenever we were dealing with our vet appointment CSV that we turned into a data frame, using .loc, because our indexes were integers, we did between 0 and 9. It selected those. We did it with iloc, 0 and 9. It selected the first 9 values, not the value of the integer, but the first 9 rows. And so that's why whenever we limited the data frame and created data frame 2 based off of all of the vet appointments that were only annual checkups, we eliminated a lot of the indexes. And so the .loc still worked exactly the same as before because it was working based off of the value of the index. The .iloc did not care about the value of the index. It cared about the position of it in the list of all of the rows. So between 0 and 3 got us the first 3 rows. And to make it a little bit more clear, we brought in this new CSV where the country name was the index instead of an actual integer. The .loc, we had to actually put in the value of the index. And the .iloc, it didn't care about the value of the index. It only cared about the integer value of the position of the rows. Now, hopefully that made things a little bit more clear. Hopefully it didn't make things any more muddy. If you have any more questions, please leave a comment. Let me know if I can clear up any of this. Hopefully you found this video informative. It's a little bit longer than the last couple of videos I made, but again, it's kind of a complicated subject, so it took me a few more minutes to explain it. So if you liked it, please give it a thumbs up. Please subscribe. I'm trying to make one of these videos at least once a week. Thanks again for tuning in, and I'll see you all around in the next video.